Okay students, now we will start with the properties of rational numbers. Alright, so first property of rational number is the closure property. Okay, what it is? It is closure property. Now, closure property is nothing but whenever I take, suppose I am considering in the number system, I am considering natural number. Okay, so when I add one natural number with other natural number, I should definitely get a natural number. Okay, like 1 plus 2. 1 is a natural number, 2 is a natural number. 1 plus 2 is what? 3. 3 is again a natural number. Alright, so I have given you that as an assignment. So please try out with natural numbers and whole numbers. I will teach you completely with respect to integers and rational numbers. Alright, so what are integers? Integers are nothing but all the positive numbers, negative numbers including 0. Alright, so closure property is nothing but something, okay, like integer plus integer should give me an integer for addition, right? Now when I'm talking about subtraction, integer minus integer should give me again an integer. Okay, then my closure property is valid. Then for multiplication, one integer multiplied by another integer should again give me an integer. Alright, then I can say that my closure property in multiplication is valid. Then when I talk about division, one integer divided by the other integer should give me an integer. If it is valid or not valid, let us see. Alright, so first thing, addition of integers. I'm talking not about rational numbers. First, we are talking about integers. Alright, so addition. I took one integer plus 3. I'm adding this with 5. Alright, so my formula is what? A plus B is equal to C. Let A be 3. Okay, let A be 3. And let B be 5. Okay, what is the formula? A plus B should give me C. That is 3 plus 5 is what? 3, 5, 6, 7, 8. Right? So 3 plus 5 is nothing but 8 or plus 8. Is plus 8 an integer? Definitely it is an integer. So plus 8 is an integer. Alright, so my formula is for addition of closure property, A plus B is equal to C. That is integer plus integer is equal to an integer. Let A be any number, any integer, 3. Let B be one more integer, 5. So again it gave me an integer only, that is plus 8. Alright. Now, when I am talking about subtraction, I know A is equal to 3 and B is equal to what? 5, right? So what is subtraction? In minus sign I should get. So instead of plus, I put minus. So A minus B is equal to C. That means one integer, when I subtract it from another integer, I should again get an integer. Alright, so subtraction, A is what? 3. 3 minus B is what? 5. So 3 minus 5 is minus 2. Why minus 2? Because my greater number is 5 and it has a negative sign. So therefore my answer is minus 2. Alright, and what is this minus 2? Minus 2 is also an integer. So therefore closure property is valid for addition and subtraction. Yeah, subtraction also. Now let us see if the closure property is valid for multiplication. Now instead of A plus B, what I will put A into B, correct? Because it is multiplication. The plus sign will become multiplication sign, correct? So A into B is equal to C. So what is A again? A is 3. And what is B? B is again 5. So 3 into 5, 3 5s are 15, right? Oh, I have taken a different example. So 5 into minus 10 I have taken. 5 is an integer, minus 10 is also an integer. So 5 tens are 15 and put a negative sign, right? Why negative sign? Because it is multiplication, correct? So 5 tens, if it was minus 5 into minus 10, then I will directly multiply 5 tens of 50, minus into minus is plus. But here only my 5 has a positive sign and 10 has a negative sign. So plus into minus is minus, 5 tens are 50. So you tell me, minus 50 is an integer? Yes, definitely. So minus 50 is also an integer. So integer into integer again will be an integer. So now what we came to do? So this is the formula. A into B is equal to C. This is the formula for closure property of multiplication. Alright. So closure property is valid for addition. It is valid for subtraction. It is even valid for multiplication of integer. Or we can say that it is closed under addition. It is closed under subtraction. It is closed under multiplication. Now let us see if my closure property is valid for division. Alright. So this is like a game changer here. Let's see. Alright. Now, I have taken a integer 7 and I am going to divide it with one more integer that is 3. So it becomes 7 divided by 3. Now you tell me, in integers, do we have fractions? We do not have fractions in our integers. There are only negative numbers, there are only positive numbers, including 0. But you cannot have something divided by something. So therefore, here in this case, my closure property is invalid. Closure property is invalid for division. Alright, so when I am considering integers, closure property is valid only for addition, only for subtraction, only for multiplication, but it is invalid for division. Why? Because something divided by something. See, this is an integer. This is also an integer. I should get an integer according to my formula. That is, A divided by B, I should get C. But I am not getting C. That is, I am not getting an integer. I would have got negative integer, I would have got positive integer. But I haven't got any positive or negative integer. Thereby, this division is not closed under, closure property is invalid for division. Alright, so again, let me just recap everything. Addition, my formula is A plus B is equal to C. We are only studying about closure property. And in closure property, you have closure property of addition, closure property of subtraction, closure property of multiplication, and closure property of division. So the formula for closure property of addition is A plus B is equal to C. Closure property of subtraction is A minus B is equal to C, where A and B are any integers. Let A be plus 1, 2, 10, minus 5, anything, any integer, you can consider it as A. And similarly, B is also one more kind of integer. Alright, so therefore, yes, subtraction, the closure property of subtraction is A minus B is equal to C. Now, closure property of multiplication is A into B is equal to C. Now, closure property of division is A divided by B should give me C, but division is not valid for closure, closure property is invalid for division, or division is not closed for closure property. Alright, so here we end closure property for integers. Now let us next see what it happens for rational numbers. See, for integers we have done, right? Same thing only we will follow for rational numbers also. So, yes. So in the last session we studied about integers, closure property in terms of integers. Now this formula remains the same, right? So A plus B is equal to C is for addition, A minus B is equal to C is for subtraction, A into B is equal to C is for multiplication, and A divided by B is equal to C is for division. Alright, so addition, closure property of addition is A plus B is equal to C, where A and B can be any rational numbers. Now in this section, I will be completely dealing with natural rational numbers. In the initial session, we dealt about integers, right? With respect to integers. Now, in this session, we are dealing with rational numbers. Alright. So, let A be is equal to 2 by 3. Okay? Let A is nothing but 2 by 3. And B is nothing but 5 by 3. So, let B is equal to 5 by 3. According to the closure property, A plus B should give me C. That is my rational number. When I add a rational number, I should get again a rational number. Alright. So now, what is A? 2 by 3. What is B? 5 by 3. Can I add them? Yes. Okay. First thing I have to see when I am adding any two rational numbers is my denominator should be same. So here is also 3, here is also 3. So write 3 as it is. Then add my numerators. So 2 plus 5 is what? 7. So 7 by 3 is again a rational number. So 2 by 3 is a rational number. When I add 5 by 3, I again get a rational number, that is 7 by 3. So therefore, closure property is valid for addition of rational numbers. So therefore, this is valid. Okay. Now let me see for subtraction of rational numbers. Now let A be is equal to 1 by 3. Let A is nothing but what this? Is equal to what? 5 by 3 I have taken. Alright. Let A be 5 by 3. Let B be 1 by 3. Alright. So now the formula is A minus B should give me C. That means when I subtract one rational number with other rational number, I should again get a rational number. So therefore, what is this? The denominator I'll leave as it is. Just subtract 5 minus 1 is nothing but 4 by 3, which is again a rational number. That means 5 by 3, correct? 5 by 3 I have taken it as A. Subtract it with what? B. What is B here? B is 1 by 3. So my denominators are same. I will directly subtract my numerators. So write 3 as it is in my denominator. 5 minus 1 is nothing but 4. So 4 by 3 is again a rational number. So according to the formula, rational number minus rational number, I should again get a rational number. So have I got it here? Yes, rational minus rational, again a rational. So therefore, subtraction of rational numbers, closure property is valid even for subtraction of rational numbers. Alright, now let me see for multiplication. Now when I multiply one rational number with the other rational number, I should again get a rational number. Alright, now 5 by 3 is a rational number. I will multiply this by 1 by 2. Alright, so in my multiplication of rational numbers, I see if it was addition and subtraction, I would have, as the denominators are different, I would have taken LCM. But here in multiplication, we do not take LCM, we directly multiply numerator with numerator and denominator with denominator. Alright, so what is my numerator here? Let A be equal to 5 by 3 and B is nothing but 1 by 2. So my numerator I will multiply with numerator and my denominator I will multiply with denominator. So 5 ones are 5. 3 twos are 6. So 5 divided by 6 is again a rational number. Alright. So therefore I can say that when two rational numbers multiply, closure property is valid here also in multiplication. So closure property is valid for addition, subtraction and multiplication. It is valid. If I am dividing 7 by 3 divided by 0, what will happen is 7 by 3 is divided by 0 by 1, this is correct. So it will become 7 by 3. Division will become into, correct? And 0 by 1 will become what? 1 by 0. Now again for multiplication, what do we have to do? We have to multiply the numerator directly and multiply multiply the denominator directly. So therefore, 7 into 1 divided by 3 into 0 is nothing but 7 1 is 7 divided by 0. Again, I got the denominator to be 0. So therefore, rational numbers, for rational numbers, division is not closed, or closure property is invalid for division. So I hope you have understood everything. For integers we have even seen now for rational numbers. So for closure property of integers, it is closed for addition, subtraction, multiplication, but it is not closed for division. Similarly, for rational numbers also, it is not closed for division, but it is closed for addition, subtraction and multiplication. These formulas are really important. Please see that you will keep them in mind, and that's all. See you in the next class. I hope you all are safe and sound. Thank you.